Welcome back to Machinist Made. Today we're going to go over tutorial 11. Tutorial 11 is pretty basic, but it's centered around general machining practices. So we're going to be going over the facing cycle, contouring, adaptive, and we're going to be doing something a little bit different, which is putting a partial chamfer around the edge of this part right here. So first thing that we always do, we create a setup. So go up here to our setup tab, create a setup, and of course we can't machine on the side of the part when our spindle's going up and down. So model orientation, ZX, Z is the top of the part, and depending on how I'm going to hold this part dictates where my Y-axis is. So do I want to stick the part in the machine like this, or do I want to stick the part in the machine this way? Now, I'm going to hold the part this way, but if you wanted to, you could turn it the other way, but I am not. The next thing we want to do is set our stock. So, Fusion automatically picks up a relative stock size, but in the world of real machining, we work in actual shapes. So, we're going to go to Fixed Size Box, and it's going to automatically size the box just enough for our part to our nominal edges, and we round up to the nearest ½ inch or ¼ inch depending on the size of the material. So X being 3 inches, well, that's going to get really close, so I want to change that to X 3.5. Our Y at 4.5 is fine. Our Z of 1 inch is not fine. We need to add some more material there. We gotta have something to hold on to, or what I like to say, make sure you're leaving enough material for the hat so we can come back and hold the part later. So again, I'm going to add a ¼ inch to this dimension right here because I want something to hold on to. The next thing we're going to do is model position. Right now the model is sitting in the position of this stock, and we want that model to be just below the top surface for our face mill. We do that by going to offset from top and changing this offset amount to 20 thousandths. If you've watched my other videos, you'll notice I always do 20 thousandths. Aside from that, we are done in here. We want to go to post process, and we're going to call this program 8011. It's going to match tutorial 11, and program comment is tutorial 11. Our work offset is G54, which is the same thing as work offset 1. Work offset 1 is the work offset your machine wakes up in. So if you're on a different kind of machine, let's say you're on a Tormach, they have work offset literally 1. You would use that 1 figuratively and literally in that software, just like you would on a Haas machine or a Fanuc machine. It would be G54. Once we've got this done, we double check that's what we want our stock to look at, and we select OK. First thing we're going to do machining wise is we're going to do a facing operation. We click on face. The tool that we're going to use, and all the tools I'm going to use, are going to come out of the Fusion 360 library. So when we look over here, a facing tool is a milling tool. We narrow the search down by clicking on face mill, and Fusion already has a 2-inch face mill uploaded in here. We're going to select that face mill, and then we're going to talk about some feeds and speeds. Let's say I'm making this part out of steel. 5,000 RPM would not be an appropriate speed. Remember, our speed is calculated by the SF, or surface footage per minute, times 3.82 divided by our diameter. That's pretty easy to figure out, but most people these days, most machinists like myself, we tend to cheat, and we just look up the manufacturer's recommendations and look at the part and go, am I really holding on to it that good to do that? And the answer is usually no, so we usually take 75% of it. I actually have a book sitting in front of me for the YG catalog, and the spindle speed it is recommending is 2,500 RPM. And a surface footage of 785. That's going to give us a that's going to give us a spindle RPM of 1499. It's saying max 2500. So 1500 RPM, and it is saying I can do up to 12 thousandths per tooth chip load. So that's going to give us 90 inches per minute on this cutter, which is pretty good. I do believe this cutter, I will double check, but I do believe this cutter is 4 flute. Let's go in here to the tool parameters. This cutter is 5 flutes, so that is actually a pretty good little face cut. So we're going to come down here, again, facing pretty straightforward. We've selected the face, we've totaled our feeds and speeds, we click OK, and it does all the math for us. It's going to figure out where the part is, because you've told it. It's going to come down and it's going to face the part off. Remember, it's only taken 20 thousandths of material off. The next thing we want to do is adaptive clearing. So the tool I'm going to use for this is a 5/8 end mill. Again, under milling tools, flat end mill, 5/8. It's right there. Select that tool, and then I'm going to select the bottom of our part and this area right here, because I need this area cleared as well. While I'm in here, I'm going to double check my feeds and speeds, and again, these feeds and speeds are a little high. This end mill is calling for 680 surface footage, which is 4100 RPM, and it's calling for a 4 thousandths chip load at full depth. So that's 50 inches a minute. We only have to change, let's change our stock to leave. I don't like leaving 20 thousandths on my radial. I like a 10 thousandths on my radial and a 10 thousandths on my axial. I will turn smoothing on because the machine I'm going to be running this on does not have high-speed machining. If your machine does not have high-speed machining, you're going to want to use smoothing. The smoothing amount I'm going to use is 1 thousandths. That is a high amount for smoothing, but I do not want to beat my machine to death. The next thing I'm going to do is verify in linking that any kind of ramp style is a plunge, because I don't want this tool to helic in and waste any time. Our stay down amount, we're going to move that to most, because I don't want this end mill picking up and down, up and down, up and down. My retraction policy for this tool is minimum. So minimum retraction, and I'm going to stay down the most I can. The lift amount, which is in high-speed machining, anytime you're doing tri-coil milling or 3-point contact milling, you're going to want to make sure your tool is picking up just a little bit at the end of the cut, so when it goes back across the material, any deflection does not drag across the tool. Remember, adaptive or high-speed machining, whatever you know the term as, even tri-coil milling, is a roughing pass. There will be deflection in the machine, there will be deflection in the tool. The tool holder, your weakest link will have deflection. So you want to make sure you've got a lift amount. Outside of this, we're done. We just click OK. The software is going to go through and it's going to figure out what the best pathing is. There's our tool path. Simple as that. Now the next thing we need to do is our finishing contour. We do that by going to 2D contour. I'm going to use the same tool, but I would recommend not using the same tool for roughing and finishing on a part, because the roughing tool can become damaged and will dull a lot quicker than a finishing tool would. So we're going to go in here and we're going to select our geometry. Again, that bottom profile will take care of all this. And then we're going to select this area right here. Actually, I'm not going to select that area, because I'm going to come back and finish that separately, because I need to finish this entire surface. So I'm going to do a contour pass on this surface. Feeds and speeds that's in here's fine. It's not going to hurt anything. Click OK. Then I'm going to do another contour for this surface right here. And I'm going to go to passes. And then in roughing passes is the only time you'll see me use this, really, is when I need to sweep across the surface. I'm going to change this to something absurd like 20 passes. My step over amount will be in 1/2 inch, because I want to make sure I am overlapping a good amount. And the only thing I got to do is select OK. And this time it actually did all of them. To fix that, we go back to our geometry. We go to stock contour and then click OK. This makes sure that we're not wasting a terrible amount of time. You can narrow this scope down even more. You can go back into edit. You can go back into contour. And in rest machining, you can just select the base parameter. Let me delete that. So back in stock contour, you can select just the outside profile of the part. And now you're not wasting any time at all. The tool's got exactly the amount of material it needs to come in here, lead in and off the part. The next thing we're going to do is a big chamfer. We're going to do a little chamfer here and a big chamfer here. So again, contour is my go-to. The tool I'm going to use under milling tools is a engraving tool. I say engraving / chamfer mill. I'm going to use a 1/2 inch, 45 degrees or 90 degrees included. I'm going to mash select. I'm going to select that surface right there first. Then I'm going to go into our passes tab and chamfer offset. I'm going to do 100 thousandths. In my chamfer width, I'm going to do a pretty industry standard 20 thousandths. Now, depending on the company you're doing work for, the company that you're deciding to create for yourself, 20 thousandths, 10 thousandths, 50 thousandths, that's completely up to you and the guy you're doing these for. I like a 20 thousand chamfer. I think it leaves a better chamfer. I also think it leaves a better looking part. Next thing I'm going to do is just simply click OK. That's going to put a nice chamfer on the part, and if we turn off our model, we can see that chamfer comes out pretty well. The next thing that I'm going to do is I'm going to put a large chamfer here, but not touch the sidewalls. Same tool. Do another chamfer pass. Turn back on my model. The geometry I'm going to select is just this geometry right here. Fusion makes this really simple. We select that contour right there. We go into our passes tab and we go, you know what? I want a 50,000 chamfer, better yet, I want a 100,000 chamfer, and the tip offset is 125. Now you have to remember, you have to give it some offset or it's not going to come out right. And then you just click OK. It does bite into the wall slightly. Let's see what that actually looks like. Bites into the wall, so we need to constrain it. Right click, edit. Under passes, the easiest way I have ever found to solve a problem like this is under tangential extension. Make this number negative. This pulls the tool back into the profile, so negative 0.450 because this is a 1/2 inch tool coming out on the arc. A bunch of complex math later, and then we are able to figure out where we need to be. So now that is a partial chamfer instead of going all the way around. And you could snuggle this up as tight as you want to by playing with that number. Let's say your customer has a call out, and I've seen this a lot, where this is literally all the way to the edge of the contour, which makes no sense to me. But that's what the customer wants. The customer gets as they ask. So this is how we do it. If you needed to follow a more complex, let's say this actually went up into the shoulder a little bit and there was some more complex geometry here in the transition, you would want to use a trace toolpath and actually model the chamfer and follow the bottom of the contour of the chamfer with about a 2/1000 offset to make sure you're not on the tip of the tool. Other than that, that concludes what I have today. Just a very brief tutorial. I wanted to show more or less this function right here, where we just simply go in. I get a lot of questions about this usually, where we go in and we just change the tangential extension to something that's realistic. And this is a little bit deeper dive onto the adaptive stuff that I've done, not done recently, but I have done in the past. Talking about changing some of this stuff in here as well as changing the stuff in our other configurations. So if you would, I'd really appreciate it if you'd like and subscribe and smash that like button. It lets the YouTube algorithm know that I actually exist and I get more than 50 views in a video over a month. Hope to see y'all back. Have a good one. Till next time.